Hello and welcome to the next edition of the BobCAD-CAM webinar series. Today's topic is 3D programming. This is day 3 of our 3D programming boot camp. All right. The goal of today's webinar to learn about surface-based toolpaths and options. As you know, my name is Al DiPaolo. I'm the voice of the BobCAD After Dark video series. You can find me on Instagram at BobCAD-CAM, #BobCAD, #BobCAM. All right, what are we going to learn about? Well, today we're going to talk about the surface-based toolpaths, some of the differences between them as far as geometry that you select, some of the different patterns that are available for you, and some of the features specific to the surface-based toolpath. So one of them is going to be extensions, so you can extend your toolpath tangentially just by editing some values. Super cool feature. The other one we're going to take a look at is leads and links. This is where the tool goes before and after the cut and how it comes in and out. The other thing that we're going to take a look at here is point distribution, how you can control point distribution in order to get better finishes. Okay, and as always with BobCAD, you can expect fewer steps, better cuts, and more profit. Now, if you guys have any questions about the BobCAD software, you can call us at anytime, 877-333-4903. Now, I do have a very special today only promotional offer. You're going to have to stick around a little bit later to learn about that, but a little goodie for you guys. So while I get my screen set up here, why don't we do a quick shout out, who you are, where you're from, what software you might be using. This is part of the 3D boot camp. So are you a Mill Pro? Are you Mill Standard, Mill Express, Mill Premium user? Want to get an idea of what levels of the software you guys are running, and then also what equipment you're running, whether you're running a Haas, a Herco, a Doosan, a Tree, a ProtoTrack. Are you tracking with Pat? You know, I want to know. So let me know, guys, and give me just a moment here to set up my screen. All right, let's see what we got. We got a bunch of people in the house today from all over the world. I want to thank each and every one of you for spending some time with me here. Mark, Stephen, John, Roger, Scott, Jim, Michael, Jeremy, Danny, Walter, each and every one of you. Thank you so much for spending some time with me here today. And today we're talking about the surface-based toolpaths, also known as 3-axis Mill Premium, also known as 4-axis Pro, also known as 5-axis Pro. Yes, this is the elite of 3D toolpaths, 4D toolpaths, 5D toolpaths, and today we're going to peel the layer back a little bit and get into some of these features here. Hey, Joe's, is it Joe's? I wonder how I say that, from the Netherlands. Thank you so much. Bridgeport XR760. Let's go. All right, all right. So I'm going to kind of pick up where we left off here previously. Richard's got Solid Edge 2020, Doosan, Fanucs, and Robo Drills. Thank you so much for spending some time with us here today. All right, so this is my part model. I don't know if it's the most complicated part model, but it's going to work for today for what we need to show. Now, building on what we've talked about previously, you want to start utilizing these job templates, right? It's really going to speed things up for you, so it definitely speeds them up for me. So we're going to create a new job. I already set up a template for day 3, and we're going to click OK. Again, when you load in the job template, it's going to load in the job. It's going to load in your tools. It's going to load in your stock. Okay, it's going to load in your zero, and it's going to load in your machining features. Okay, so you can customize that tree however you want, have whatever feature set up there. And again, this makes it quite a bit simpler when you're looking at getting going on jobs. Okay, it's a great jump off point. I'm going to focus on 3 of the premium toolpaths, or the surface-based toolpaths. We have Morph, we have Parallel to Curve, and we have Flowline. Okay, so to begin with, what are the surface-based toolpaths? Where do you get at them? What do you have to have in order to have access to them? Okay, so if we right-click on our machine setup here, and we come down to where it says Mill Multi-Axis, this is where you're going to find the surface-based toolpaths. Okay, so Mill Multi-Axis. in here under the surface area, these are all the surface-based toolpaths that you have, or that BobCAD offers, or that are available. Okay, parallel cuts, cuts along a curve, morph between two curves, parallel the multiple curves, project curves, morph between two surfaces, parallel the surface, and Flowline. These are your surface-based toolpaths. Now, how do you get access to these toolpaths? You need to be a 4 Pro user, 5 Pro user, or if you're just doing 3D machining, you can be a Mill Premium user. Okay, all of these toolpaths work in 3, 4, or 5 axis. Okay. Now, again, if you're uncertain about what you have on your license, let me see here. I can go to Help. Okay, if you go into under Help, you can click on Show License Status. All right, and this will show you all of the different packages that you may have purchased or are on your license. Okay, so this is going to be 3 Premium is when you'll gain access to these strategies. If you're a 4 Pro user, you can use these strategies in 3 or 4 axis. If you're a 5 Pro user, you can use these strategies in 3, 4, or 5 axis. Okay, so that's a little bit about what you need in order to gain access to these toolpaths. It's also a little bit about which toolpaths we're talking about. All right, so to begin with, what is the biggest difference between, you know, like a Mill Pro or a Mill Standard toolpath versus the Mill Premium toolpaths or the surface-based toolpaths? Okay, so what is the biggest difference? I'm asking you guys, what do you think? What's the biggest difference? And I guess it's kind of a loaded question because you could say a bunch of different things. Okay, but anybody have an idea what the biggest difference is, or what I'm thinking about the biggest difference being? No? Okay. The biggest difference for me is your selection. Okay, so like every other, like day 1, day 2, right? When I talk about selecting your geometry, I'm recommending you select the entire model, right? So you select the whole model when you're using a Z-level rough or a Z-level finish or a planer, okay? When it comes to these surface-based toolpaths, we are not selecting the entire model. Selection is one of the biggest differences between the surface-based toolpaths and the other toolpaths, okay? So instead, when we're working on a morph or a parallel to multiple curves or a flow line, you know, our selection process does not look like this. We don't go like this. We're not going to select the whole model. There's a number of reasons why, but mainly because these toolpaths have a lot of control and options, and they're best for targeting drive surfaces, okay? And the drive surfaces could be made up of multiple surfaces, but it's unlikely that you're going to try to drive toolpath across all the model, okay? So we're not going to select the whole model, but instead, we're going to be a little more particular about a surface or a series of surfaces we want to work with, right? So if we select for this flow line here, and we pick this one surface here, for Flowline, that's going to do a good job at just generating toolpath on a single surface, okay? Any single surface that we want to work with, we can select that surface, okay? And using Flowline, we can come in here and be able to clean up that area, okay? When you're dealing with Flowline, that toolpath is either going to go along this the UV lines or against the UV lines, okay? So we'll talk about that a little bit more. But again, with these surface-based toolpaths, generally we're looking at single surface selection. We have to pay a little more attention to the surfaces that we select. That's a huge difference between all the other toolpaths and the surface-based toolpaths. Now, the other thing that I want to kind of take a look at real quick that ties into that has to do with surface normals. Now, on your main, in the CAD space, there's this toolbar here that's always here. It's on every system, okay? Everybody's system. You can't remove this toolbar here. And this one all the way on the right here, this says surface normal. If I click this, we're going to see all these little dots, right? These lines that come up. And essentially, that's indicating the positive direction of that surface or that surface normal. All right, now this is important because as you're selecting these surfaces and you're targeting where it is that you want to cut, you want these surface normals pointing the same direction. If you have some that are pointing down and some that are pointing up, you're going to see the toolpath switching on which side of the surface it's trying to cut on. Okay, so the side of the surface you want to cut on, it's generally the direction you want that surface normal being. Okay, if you need to change a surface normal, okay, how do you do that? Well, let's see. What do we got? Under create 3D, or no, utilities. It's under utilities here. Reverse surface normal. Okay, so using reverse surface normal, I could select on one of these faces here, and then I can switch that surface normal. You can see this line right here. It was pointing up. Now it's pointing down. If I want to switch it back, I can select it, choose OK. Okay, that allows you to switch which direction the surface normal is. Does that make sense, guys? Let me know if it doesn't. All right, so that, again, the takeaway to begin with is the surface-based toolpaths. You're going to be more selective. You're not going to select the entire model. You're going to pick specific drive surfaces you want to drive the toolpath along. Okay, and the other takeaway that we have here is your surface normals play a role in which side of the surface the toolpath is being generated on. If you need to invert a surface normal, again, you can do this under utilities, reverse surface normal, select the face, and it will switch it. All right. Now, so we talked about the difference of geometry selection. We talked about the role surface normal plays. The other thing to understand is these toolpaths here, these toolpaths can be utilized in 3, 4, or 5 axis. Okay, I understand this is a 3D programming boot camp, but as you continue to grow in your shop, you're going to go from 3-axis to 4-axis to 5-axis. It's the natural progression. So getting familiar with these very powerful toolpaths will help you as you continue to expand in complex parts and utilizing different machine configurations. All right, now if you're a mill premium user, okay, when you're in here under tool axis control, all right, tool axis control will control whether this will post in 3-axis, 4-axis, or 5-axis. All right, if you're a 3-axis mill premium user, it would be defaulted to 3-axis. You wouldn't be able to do any more than 3-axis. If you are a 4 Pro user, then you'll be able to limit the output in 4-axis, or if you're a 5-axis user, then you'll be able to control 5-axis tilt in, as far as the 5-axis of motion or 5-axis output. Okay, so in 3-axis, we don't have to worry about tilt. When we get into 4-axis, this is where you can start controlling tool axis and tilt in the way that the tilting is done. And then when we go to 5-axis, it expands upon it and you have even more control. All right, so the mill premium toolpaths are the surface-based toolpaths used in 4 and 5-axis machining the world over, okay, but just limited to 3-axis, okay? All right, so you can, all of the toolpaths that were shown here today, it's possible to be able to also use them in 3, 4, or 5-axis. So this is good knowledge, good familiarity for you guys to get into. All right, so, all right, if there's any questions about the surface-based toolpaths, go ahead and fire away. Otherwise, I'm going to keep getting into what I got here. So you guys got any questions, fire? Otherwise, we're going to keep going. All right, looks good. So, surface-based toolpaths, let's take a look at some of them. All right, so the first one I want to look at is really just this flow line. I'm just going to start with the flow line to begin with, okay? All right, if we were going to create a flow line toolpath from scratch, it would look something like insert mill multi-axis, pick the surface-based toolpath, we'll choose flow line, okay? We can go next, or you can run through the navigation here. We can enter our tool information. Okay, then we're going to get to our parameters. Now, all of the surface-based toolpaths look the same way. We have tabs across the top here. So you got surface paths, you got tool axis control, you got gouge checking, you have a links tab, you have a roughing tab, and you have a utility tab. Okay, so there are a ton of options within these strategies. Me personally, I do not recommend a new user that isn't familiar with 3D programming to jump right into the Mill Premium. There's a lot of options in here, so you may start with a Pro and then, or a standard to Pro and then a Pro to Premium, but there are a lot of options in here. So, to really get the most out of the software, you're going to have a learning curve. It's not crazy, but again, more options, more control, more learning. Okay. So again, we're going to pick a surface-based pass. We want to pick a drive surface. A drive surface is where we want the toolpath driven along. This is Flowline, so we're going to click drive surface. We'll select one of the drive surfaces. This is the surface we want to create the toolpath on. We'll say OK. All right. Now, from there, again, you got your tool axis control, you got your gouge check, you got your links. What we're going to do to begin with is just compute this. And we can see that there's some toolpath generated on the screen. Okay, so one of the unique features or one of the value features of the surface-based toolpaths have to do with extensions. Okay, right now we're cutting in a single direction. You can see how when I backplot this, let's get to a front view. Okay, you can see how the tool is starting right on the surface, and then it's extending past it. It goes to clearance. Okay, so it's coming up and coming over. So the first thing I wanted to talk about was extensions. I want the toolpath to extend out to start off the part and to extend past and to finish past the part. Okay, now if you've watched some of the previous webinars, we talked about extending geometry, boundaries. There's a couple of different things you can do with like a Mill Pro or a Mill Standard. When you're in Mill Premium, this is where you have extensions built right in. Okay, so you can just go to the parameters in the area type here. Okay, there's this option that we can check on called extend and trim. All right, so we can choose extend and trim. Now there's tangential extensions, the left and right side, and then there's also side extensions, the top and bottom of the surface. On the tangential extensions, you can use a positive or negative number to extend past or trim. On the side extensions, you can only do a positive extension. You can't trim it back, okay? If we look at our, let's just say 100% of the tool, we'll go like this. We'll say OK, recompute, and now you can see the toolpath will start and finish off of that surface. Okay, so that's again just an example of extensions using Flowline. All right, let me delete this guy. All right, extensions using Flowline. I want to jump into Morph. Morph is another very popular toolpath. Again, there's a couple of settings you need to define for Morph. You have the drive surface or surfaces you're driving the toolpath on. You have the upper curve, and then you have the lower curve, and the toolpath is generated along the surface between, blended between the upper curve and the lower curve. Okay, this is a very common toolpath, very popular toolpath, right? So let's take a look. I'm just going to select some of these surfaces here on this radius like this. This is a very common scenario that I tend to use Morph with, is if you have a radius you're trying to machine on a compound curve and you want the toolpath to follow along those areas, this is a great way to do it. Okay, so we select our drive surfaces. The next thing I'm going to do is pick my upper curves, right? So this is my upper curves. I don't know if I went all the way across. Let me see. Okay, so wherever my drive surface is, I want to select these all the way across as my upper curves, right? So you can see I only have a section of it there. So let's get this one and this one. All right. So that's my upper curve. Then I'm going to come down to my lower curve. So this is the bottom side of it. So I'll just select these edges here. Okay. A lot of times when I'm trying to select edges like this, I'll left click in the CAD space, hit S on my keyboard. I can turn the shading off. This makes it a little bit easier to be able to pick those edges. Okay, so we have our drive surface. That's where we want the toolpath being driven on. And again, this is a morph strategy. So we're going to morph from the upper curve down to the lower curve. Let's go ahead and compute and see what we get. All right, so this gives us our toolpath to come in here and machine that area. Let's go ahead and backplot this. So we can see it starts at the upper curve, and then it works its way down towards the lower curve. This is a zigzag toolpath, so it's going to work its way back and forth. Again, another good aspect or great aspect or just something you should be aware of. You will notice that the tool will roll over past the tangency point. So you're going to get good cleanup on this. Okay, so we can see how on the front view here, the tip of the tool, where it's located. Let me back up. Okay, and we'll see that we're getting a tangency point here. You can see how this is past the tangency point of where that radius is. Flowline in V31 Premium. Yes, that is correct, Vincent. Flowline is available in V31 Premium. Okay, so again, that's just an example of a morph style toolpath. One of the topics today is extensions. So this is my drive surface, upper curve, lower curve. What I want to do is I want to get this toolpath to extend out further, right? So how can I do that? Again, I'm going to edit the feature. I'll go to the parameters. I have extend and trim here. I can use these as a value. Okay, so this is a negative number. So I can go positive or negative, or I can, oh, hold on, let me just make these two positive. Okay, and we're going to say okay, and then we're going to say compute. All right, and we'll see how now the toolpath, instead of trimming back there, you can see how we can extend it out. Now, again, something you have to pay attention to is some of these other surfaces here. So we can see this toolpath is working its way back and forth. When we did our extension here, okay, you can see how the tool's running into this other surface, right? Okay, so when you're working with your surface-based toolpaths like I'm working with here, the drive surface and these upper curves and lower curves, these are the things that the software is paying attention to. So these other surfaces over here, they could be problematic. Now, you do have the ability to check things away. Let's go ahead and get into that real quick. If I do want to make sure the tool doesn't run into any of these other surfaces, I could do check the tool flute and shank. I could say these check surfaces here. I just want to make sure that the tool isn't running into any of these areas here, so I can select those. And then I can say if the tool comes within 15 to retract the tool along the tool axis, I can recompute that. And then those check surfaces, like before we saw that the tool ran into it, now what it's doing is it's bumping that tool path up and out of the way so it's not running into that surface. I don't know if that would be my approach in this particular example. Again, I'm just trying to demonstrate the patterns that you have with Morph, parallel to multiple curves and flow lines, okay? Regardless of whatever strategy, Morph, parallel to multiple curves or flow lines, you do have extensions. And again, those extensions will be found under the area section. Okay, let's jump over to the parallel to multiple curves. Now, let me get in here again. Let's go to mill multi-axis. Okay, so we've done flow line. Flow line, you can select a single surface, and it will use the X, Y, UV lines in order to control where the tool path is being generated. Okay. The other one that we're working on here is morph between two curves. This is a blended tool path, so you select your drive surface and your two curves, and the tool path will blend between those two areas. All right, and the other one that I'm working with today is going to be parallel to multiple curves. Okay, this one you select the drive surface, you select curves, and you get parallel toolpath to that curve. These are popular toolpaths. I use them all the time. Now, it's also important to understand, even though I'm not showing any undercut examples, all of these toolpaths support undercuts. Okay, so you can use all of these toolpaths if you have negative draft. You might be breaking an edge on a through hole. I mean, there's a lot of different scenarios. You might be breaking an edge up on a contour. A lot of different options that are in there. Okay, so morph, again, we did our morphing routine. We talked about check surfaces real quick. Parallel to multiple curves. Let's take a look at this one here. I'm going to select my drive surface. My drive surface is going to be this area. That's where I want the toolpath to be driven on. Mike, if the screen is freezing up and it's breaking up, that may just be either your internet connection or my internet connection. Let me see if is anybody else having an issue with delay in the broadcast or in the audio, just comment so I can check. All right, no, no, no. So I got 2 no's so far, 3 no's, nope, nope. So yeah, Michael, that's just your internet connection. I apologize. You have signed up for the webinar, so you will get the replay link. We'll send that out either later today or tomorrow, so I do apologize for that. All right, so again, I'm selecting my my drive surfaces here that I want the toolpath being driven along. Okay, so that's my drive surface. And then for parallel to multiple curves, you have to select an edge curve. Okay, no problem, Mike. That edge curve, in this example, I'm going to pick this edge here. So what I want to do is I want to drive the toolpath along our drive surface following these edge curves here. Okay, so this would be kind of like a pencil or a cleanup type toolpath. All right, let's go ahead and compute this and see what we get. All right, so that's the toolpath. Again, to come in here and run in with a smaller ball mill and clean up those areas there. All right, now again, we're talking about extensions. So if I wanted this to extend out further, I can edit this feature. I can go to parameters. In the area type here, there's extend and trim. You can either use a percentage or a value, and it can be positive or negative. So you could extend out or trim back. In this case, I'm going to say extend out by 100%. We'll go ahead and recompute. All right, and then we can see how that toolpath is now extending out past the edge of the part. This is a really good option. Okay, so again, Morph is going to give you a blended toolpath along a drive surface between 2 curves. Parallel to multiple curves, this is going to give you parallel toolpath to your edge curve along your drive surfaces. Okay, and then the other one here, this is Flowline. Right, so Flowline, you can select single surfaces, and it's either going to follow the X, Y, or UV. Okay, in this example, you can see it's following along this direction. What if I wanted it to run up this way? Again, you can come in and edit and go to your parameters. Instead of along, we're going to say around. We'll go ahead and recompute. It says my drive surface is missing. So let me go ahead and select one and recompute. All right, so now you can see it's going this way. All right, if we come back in here and edit this, and we go to parameters, and we say along, and we hit compute. All right, so now you're going to see it's going lengthways versus across the width, or parallel to X versus parallel to Y. All right, so again, all 3 of these toolpaths, these are 3 of the, I think there's 9 of them. That are in the surface-based toolpaths, all of which will give you your extensions. All right. All right. So let's see. We got our morph routine here. Let's go ahead and just show these in a couple of different areas. Right. So I'm going to remove some of my selection here. All right. This one here. I'll leave that one for now. Flowline is okay for now too. All right. So let's look at this morph strategy again. All right. Let's go ahead and recompute. That should go away. All right. So another example of a morph style toolpath. Let's go ahead and select along here. All right. So that's going to be the drive surface that I want to run along. All right. My upper curve, I'm going to say, is this top edge here. As such. Okay, so that's my upper curve. My lower curve, I'm going to say, is this bottom edge here. As such. All right, looks good. Let's go ahead and compute. See what we get. All right, so this has given us our morph style blending between these 2 areas, again, working its way back and forth. Again, you got to pay attention to the neighboring surfaces, right? So in this case, you can see how the toolpath is going down further because the tool wants to go to the tangency point. Okay, can you take multiple side passes? You can take side passes, okay? Each of these toolpaths can be broken down a variety of different ways. and they can be patterned, and they have a lot of different options. Okay, so I'll get into that. That's not quite my topic here right now, but I'll get into that a little bit here in just a moment. All right, so we can see how this toolpath is blending down along that wall, but it's running into these floor surfaces here. So again, that's how you're going to use your check surfaces in order to check it back or to stop it from cutting an area that you don't want, right? So this one here, we're going to do morph. I'm going to reselect this. Let me clear those. That's probably why we saw some of it on the walls there. So I'm going to select those areas as well. We'll say OK, recompute, and we'll see that toolpath is checked back. And then instead of it running down into the floor, we can see how we stopped it so it's not going down in the floor. Okay, so again, that's just another example of a morph style. Okay, let's go into parallel to multiple curves. I think the example along this or along this bottom radius is a good option, but again, you can you're not limited to just this scenario. It could be any scenario. So let's go ahead and remove and remove. Okay, so let's say we wanted, this wall happens to be a vertical wall. There's no taper on it, but let's say there was a taper on it and we wanted to machine along this surface here. Again, we could select that surface. That's the surface we want to work with. And then we can select our edge curve. Our edge curve would be this bottom edge. Let's go ahead and compute. All right, and here you can see by selecting that bottom edge curve, you can see how the tool's trying to go back and forth in that area, working its way down from there. If we remove that and select this top edge curve here, hold on, this top edge curve here, okay, and compute, then we can see we can get a parallel toolpath following along that area. Okay, so this one I actually have set up for zigzag cutting. Let's see, so this is starting at the bottom and working its way up towards the top there. When you get into these strategies, there are different options as far as like below the area type. The area is where you're going to find your trim and extend, right? So, but below that, you're going to see this flip cutting order here. You can use that to change what direction the tool works its way across. So you could see before it was starting on the bottom. Okay, so you can see before it was starting on the bottom and then working its way up, and then I just use that reverse cut order there, and you can see now it's starting from the top and working its way down. Okay, all right, so let me see. So this is parallel to multiple curves. Again, we did a little different morph example. Okay, we did our parallel to multiple curves, and again, extensions, right? So we can edit on this. We don't want it to start right on the edge of the part. We'll go to our parameters here, extend and trim. We're going to extend by 100%. We say OK and recompute, and then this will extend that toolpath out so it starts and finishes on the end of the part. Okay, so again, parallel to multiple curves. Let's look at another example of this one. Let's remove and remove. Okay, let's pick this. Let's pick this drive surface here. Actually, I don't know. Let's do it this way. Let's pick that as the drive surface. Let's pick this as the edge curve. Let's compute it and see what we get. Okay. All right, back plot. We can see this is working from that outside in. Again, you don't have to be cutting in a single direction. You could be cutting in multiple directions. All right. Let's see. Jerry was talking about, can you take multiple side passes? So let's see if I can show one of those. Flowline doesn't really have multiple side passes. Morph, can you work in parallel? Kind of allows you to do your own side pass. So let me kind of show you, Jerry, where some of those settings are. If you get into this roughing section here, you have stock definition. Stock definition is going to let you use your setup stock, and it will trim toolpath that's outside of the stock. And then under here, under the parameters, you have some options to shrink or expand and how to control what happens when the when the toolpath is outside of the stock area and some of the options that you have for that. Okay. The other one you have here is multi-passes. You could generate like a finish pass, and you could have roughing passes working its way in X and Y. You can have finish passes. So this is one of the ways in which you can generate a pass and then turn it into multi-passes. This one here, this is for depth of cut. So this will let you rough down in Z, and you have different options for that. This is your transform pattern. So this is where you can program some toolpath and be able to pattern it away. So you have one instance of it and you pattern it in other instances, okay? And then the other option, you have some sorting options, because as you start adding passes and things like that, you may want to reverse the order in which it cuts and things like that in order for everything to turn out the way you want. Okay, so if you're looking to do some multi-passes, you can come in here, turn the number of passes on, add the spacing, and you can add your multiple passes. I'd like you to show an example, use 4-axis multiple indexing, an example of top and side, please. Brian, I can't do that today because today is 3D programming boot camp, surface-based toolpaths, and you're talking about 4-axis. I will be doing a 4-axis webinar coming up, but not quite yet. Okay, so I'll let you know. Keep a lookout for your inbox for that. All right, so we talked about extensions. We talked about some of the different idiosyncrasies of these options. You have tangent extensions. Let me do so far when I've shown the extension, we're in here under extend and trim, so we can extend the tool out 100%, a positive, negative number on the side extensions, but then sometimes you need, on the tangential extensions, sometimes you need side extensions as well. So you want it to start off the part in a different direction. So you have side extensions as well. Now you can only go positive on the side extensions, but again, this will maximize the area of that. Again, this is doing it with 100% of the tool. I didn't have to edit any boundary. I didn't have to change any of my selection. All I did was come in and adjust parallel to multiple, came in and adjusted what the side extension was. Okay, again, you'll find that under parameters, extend and trim, and your tangential extensions are up here. Your side extensions are down here. All right. The next area that I wanted to get into, I spent a lot of time on that, so I apologize. The next area I wanted to get into has to just do with leads and links, okay? All right, so let's turn this off and recompute. Okay, so right now, you can see how the tool is just plunging right down. There's a vertical lead in. It works its way back and forth across this surface, and then it comes out. If you wanted to add a lead in or a lead out, you can do so. Let's take a look. Let's edit our operation. Let's go to our links tab. Okay. Now in the links tab, there's a couple of things that are happening here. Number one, your retract values are set in links. Okay. So this says, how far you're going to retract up. You'll notice that this says plane, cylinder, or sphere. So in 3D machining, you're probably just going to be on a plane. As you get into 4-axis, it might be a cylinder. As you get into 5-axis, it might be a sphere. Okay, so this is just 3D. So we're going to look at a plane, and this is the clearance plane that we're defining here. Okay, all right. So that is a little bit about your retracts, but your lead in and lead out. Now, I want you to pay attention to something. Over here on this side of this page here, okay, you have a couple of different sections: entry, exit, gaps along a cut, links between slices, links between passes. Okay, you're going to notice it says don't use lead in and lead out, or use lead in and lead out. Okay, don't use or use. So this is what allows you to set a lead in and lead out at the beginning. Where it says entry and exit here, this would be at the beginning of cut. So I'm going to say use lead in. This one I'm going to say use lead out. I'll recompute, and then my expectation is there's a lead in and lead out now. Okay, so this one looks like just a circular lead in. You can see the tool will come in, cut all that stuff, and then the tool will come out. All right, so when you're in here, what you can do is edit the defaults for your lead in and lead out. See where this says default lead in and lead out? You can click this, and then now you can configure what the lead in style is and what the lead out style is. Okay, so let's look at maybe a different one. We'll do a vertical tangent. We'll add one over there. We'll compute that. All right, so now instead of it coming in from the side, you can see now it's going to radius in from above. Okay, now as far as the size, it's all based off of like a percentage of the cutter. Okay, so which is nice, right? So you can come in here again under your default lead in and lead out. You know, maybe you only want this to be 50% of the cutter for the swing. So you can adjust that. Now you have a smaller vertical lead in radius style that goes back and forth. Okay. All right. And that one comes out. So the takeaway here on the lead in and lead out is you go to the links tab. This is where you're going to find the lead in and lead out options. Okay. On the entry and exit, you can use lead in or use lead out. This little button next to here, this says whether you use the default value or whether you come in and adjust it. I recommend using the default value. It makes it really easy to come in and adjust what your lead in and lead out is for the job that you're working on. Okay. All right. So entry and exit, lead in and lead out, use lead in, use lead out. Okay, you got default lead in and lead out. And again, you have a variety of different options that you can work with. Let's do just tangent line. All right, we'll say okay and compute. Now we can see our tangent line just coming in here and working its way back and forth. Okay, so you got a lot of different options. That's the first lead in and lead out. Now you guys are used to lead in and lead outs. You know, maybe you've been running Mill Pro or Mill Standard and you've always had a lead in and lead out. So what's different about this surface-based toolpaths? Well, there's a couple of things that are different, like being able to use a lead in and lead out for the gaps along the cut. Okay, so a gap is like if there's a hole in the model or a gap within the surfaces, you have two different options or two different sections that would apply. You have small gaps and large gaps. Now, a small gap is defined as 20% of the tool diameter, or you can come over here and type in a value. So basically this, by using small gaps and large gaps, you can tell it to maybe jump over little holes, but retract and go to clearance for larger holes, right? There's different strategies that you have to tell the software what to do when it encounters a small gap or when it encounters a large gap. Probably the most common thing that that people see here, let me just go like this and recompute. The most common thing that people a lot of times see is this retract where it ends up going to clearance between every cut. And usually that's your small gap options not being set to this. Let's make links between slices. Let's say, let's do this here. Let me see. What am I trying to do? I'm trying to show you. This is direct. Let's say retract to rapid and recompute. Okay, so you can see how, it's a deep subject. Okay, so there's only so much I can cover in the time that I have here, but you know, I'm starting to break down this tangent line here at the beginning and exit, right? So that was from your leads. These, as it steps over, these are your step over amounts. And usually what I'm showing you here are these clearance positions. This is just really common of what comes up. Now, you can use these in a variety of different ways. The fact is you have control over them now. Okay, and all the other levels of software, Mill Pro, Mill Standard, Mill Express, you don't have control over these lead and links like you do here. Here I can tell it what I want it to do. You know, maybe I don't want it to go to a rapid to clearance. Let me do like clearance blended spline. Let's see what that one looks like. Okay, so you can kind of see, well, this one just is rounding over these edges here, but you have a lot of different choices to handle your lead in, lead out, and link options. Okay, more than I can really go over in today's webinar, but what's important to know is that you are in control of what happens at the beginning, the end, and what happens in the middle, and it's using these leads and links options in order to control it. Okay, so as another example, if I wanted to use the lead in and lead out between each of the slices, I can add that in here. Okay, and it's adding a lead in and lead out. Now that looks a little strange here. Not all the combinations of options make sense. But let's kind of set this to retract to rapid, use lead in lead out. Let's recompute. Oh, it's using the tangent lead in and lead out, the default one. Let me go ahead and change that. So let's go back to, instead of a tangent line, let's do the vertical tangent like that. Let's do this. Okay, compute. And that will look, again, the numbers are a little bit weird, but that you can see how now I'm using a radius lead in and lead out between each pass. Now, some of them you can see they're not using the lead in and lead out. And again, that's just based off the setting that I have here under links. This is saying use lead out only. Okay, so I could say use lead in and lead out. Let me adjust this value here. Let's make this something like this. All right, so now you can start seeing how you can adjust the lead in and lead out for each one, and again, be able to dial in what's going on there. Now, what is a good example of where this might make sense? Let's go ahead and let's get into this one here. Let's go to our leads. This is going to be direct. This is going to be no. Let's do this. Let's say one-way cutting and compute. All right, so right now I have a lead in and a lead out, but if you look at the tool between each pass, you can see it's going really high up to clearance. Now that may be necessary in some scenarios, but may not be necessary in all scenarios. So what can you do to kind of knock it down and keep that tool closer to the workpiece, right? So we can get back in here under links. Okay, instead of retract to clearance, I'm going to say retract to incremental clearance plane. I can go to my retract table here. I can set what this number might be. I'm going to make some adjustments to some of these other numbers here. We'll say okay and recompute. And then what this will do is bring those rapids down. You can see how now they're staying closer to the workpiece versus going all the way up to clearance. Okay, so this is, again, providing more control. You know, a lot of guys, even though this is just a flat, like an angled surface here, there's a lot of scenarios where you may want to keep the tool closer to the workpiece. This allows you to do that. Again, this will help you speed up some of your cycle times, even on simpler type geometry sets. Now, the other thing that I want to touch on here, again, under this utility here, right now we're rapiding back at a rapid, dog legs. Maybe you don't want to do a rapid. You can come in here and say use rapid feed rate, and you can give it a number that you want that feed rate to be. Okay. And then now, instead of it being done as rapids, it's done as a mapped feed rate. Okay, so you got lots of different options there when it comes to lead in and lead out. Okay, so the takeaway here, number one, is links is where you're going to set your clearances and lead in and lead out styles. Okay, that's number one. Retracts is where you set your clearances. Okay. You have your entry and exit. You can tell it to turn your lead in and lead on out. Okay. And you can use the default lead in and lead out in order to make adjustments. Okay. So this way you can try different styles or what have you. Now, in between the cuts, between passes, or links between slices and gaps along the cut, you have different control, whether small gaps or large gaps. And you also have the option to use no lead in and lead out, use lead in only, use lead out only. Okay, so those are the takeaways that I have about lead in and lead out and the links. Again, there's a lot of options here, more than I can cover in a single webinar. But just like other features you've seen in the version 32, you know, some of these options you may want to default a specific way. All right. You can do that by saving a feature. You can do that by customizing the machining strategy, a user-defined machining strategy, right? You can do that by job tree templates. You can also do that by wizard defaults, right? Wizard defaults, system default parameters. So you can save these. You can go in here and set up what all the different options are that you typically use, and you can save that as your default so you don't have to go through and make adjustments with it. Okay, so again, that's a big takeaway. All right, now the next thing I want to talk about is point distribution and the control that you have for point distribution. I mean, there's hundreds of features within these surface-based toolpaths, quite a bit to go through, but I wanted to talk about point distribution. I'm going to use the Flowline toolpath that we have here, or, you know, let me actually do it. Let's do it with this one here. Let's do it with the parallel to multiple curves. Let's turn this one off. Let's keep that one. Let's turn this one off. Okay, so this is the parallel to multiple curves. That's the drive surface. That's the edge surface. That's the toolpath. Okay, when we get into simulation, because I mean, I have the ability to check what the points are in backplotting. I can click through it and see what they are, but it's a little bit easier to see what's going on here when you're dealing with simulation, because we can show our toolpath points. Okay, so these are showing us the points that are making up the toolpath. The points would be the movements, right? So how many movements there are, how close they are together, this type of stuff. And when you're dealing with 3D machining and you're trying to get the best finishes, your point distribution becomes a topic of interest, and control that you have over point distribution. Now, as a mill standard or a mill pro user, you don't have control over point distribution. What you generally work with is this allowance, right? Machining tolerance. You'll increase this number, you'll get more points. You decrease this number, you get less points, but you don't really have control over the point distribution, how evenly they're created, etc. All right. When you get into the mill premium, you do get into point distribution. Let's go ahead and take a look at where that is. All right, so we're going to be under our parameters tab here, and we're going to look at advanced here. So when we get under advanced options for surface quality. So you got a couple of different options here. Number one, you have approximate or exact step over. All right, so right now we have this set to exact. Number two, you have toolpath smoothing distance, detection angle. So this will smooth out your toolpath, and there's values you can use in order to adjust it. You're trying to get rid of hard moves and smooth everything out. But that's not what we're talking about. Here we're talking about point distribution. Okay, so we can add more points, or we could take points away. You know, you have control over it. You can give it a max distance. You can give it a minimum distance, and you can give it a deviation factor. So if we say a max distance 0.01, for instance, and we recompute our toolpath, my expectation is we're going to get more points on our toolpath, right? So if we look at our toolpath, you know, now we're seeing a bunch more points as far as making up this path. Nice and consistent all the way through. Okay, so on this particular surface, you know, I don't have a lot of toolpath here, but as you get into other surfaces, you're going to see that point distribution, and really that's affecting the quality of your surface. If you want the best quality surface, depending on the machine you're running, some machines want less movement, some machines want more movements. Okay, so depending on your machine, you can start controlling that point distribution, or the way those entities are broken up, to feed your machine what it wants in order to get superior finishes. And really that's what it's all about, is getting superior finishes, right? So point distribution, you're going to find this in all of the, I believe, in all of the surface-based toolpaths here. Let's take this one and let's get rid of extend and trim. Let's make this something like that. Let's recompute. All right, so that gives us our morph here. Let's turn this one off. All right, now from here, let's turn this on. We'll go in the simulation. Take a look at our points. You can see, the point distribution, what we're getting along these edges, where we have more points, where we have less points, right? And then we can go in here and adjust this under the point distribution. So we can say edit, parameters, advance. Again, point distribution. You can make this number bigger. You can make that number smaller. Let's see what it does. All right. Now, for those of you that are with us here today and you stayed all the way through, okay, and I know there's a handful of guys that are in here still, I have some great news for you. I told you about this earlier. It's day 3 of our 3D boot camp. We've gone over some basics. We've gone over some more complicated stuff, a whole range, 3 hours of webinars on 3D machining. So I hope that you guys really appreciate and are taking advantage of the information that we provided here. Okay, so the other the reward you guys get, some of you have been here for just one day, some have been here for all 3 days, but the reward is we have a special discount for you here today if you upgrade your software from one level to another. Okay, and Dane, I'm going to answer your question here in just a second. Okay, so what the takeaway here for you guys for being with us, joining today's webinar. Okay, if you're going from Mill Standard to Mill Pro, and you call in today and place your order, you're going to get $295 off that order. Okay, so whatever the price is, you're going to get $295 off of it. If you go from Mill Pro to Mill Premium, this is like level up. If you level up your software today, or let's say you go from version 30 to 32 or 29 to 32, if you call in today at the 877-333-4903 number and you order and level up today, you're going to get $295 off your order when you call in with promo code The Wiz. Okay, the promo code The Wiz is for if you attended today's webinar. This is a today only deal. Okay, so if you guys want to jump up to Mill Premium, you can save $300 by doing it today. You got to do it today. You got to call in the 877 number. Promo code is The Wiz. Okay, so definitely take advantage of that if that's something you're looking to do. If you want to get into the Mill Pro, if you want to get into the Mill Premium, yeah, you're getting $300 off or $295 off if you call in and order today with the Wiz promo. Okay. Other than that, I'm gonna hold back and get through a couple of more questions with you guys here, but I'm gonna wrap up the recorded webinar at this point. So give me just a moment here. Again, with BobCAD, as always, you can expect fewer steps, better cuts, and more profit. Take advantage of the Wiz promo today. Call 877-333-4903. Call in and level up or upgrade today. Mill Express to Mill Standard to Mill Pro to Mill Premium, or upgrading from any previous version. $295 off when you call today. 877, call and order today. 877-333-4903, promo code The Wiz. I look forward to seeing you guys in the next webinar.